Hi everyone. So this is linkage design part 2 because in the linkage design previous section that I didn't have courage to talk about because that we didn't have time to talk about some other more complicated linkages. So in the first section that we go through some very basic rules about what is a 4-bar linkage, what are the conditions to create different kind of motions for a 4-bar linkage. And also we talk about how could we, for example, that make a 5-bar linkage work? How could we try to replace a P with an R while not changing the system's dimensional freedom? Which means that it will work. And also how could we combine different kind of 4-bar linkages together? And also that how could we add just 2 bars in between two points that already have a blue track so that it will also work? How could we add a lever? A bunch of things. So now I'm going to show you some more examples. First, I'm going to draw a 4-bar linkage. So we all know that this is going to work. And yeah, and also that it's possible we can combine it with another 4-bar linkage. So in this case, we can also do something like this, that we can add another bar and to here. So from here to here is a 4-bar linkage, and from 2, 5, 6 is another 4-bar linkage. So now we can see it's working and how it moves. I want it to finish a full loop for this crank too, so I'm going to adjust the points position a little bit. Okay, now it's working. Great. And another rule I didn't talk about is that we all know that 3 points will define a plane, and also a triangle is the most stable like structure. So if you see a triangle, that means that this is going to stable, it's not going to be flexible. You can see that this 4 bars is actually quite flexible when we move it, but a triangle, a 3-bar will never work. That this is just going to be rigid, as you can see. Another rule I want to review is that in between two given point that already have a track, for example, this point already have a track like swaying from here to here, and this point also have a track like swaying from here to here. So in between these 2 points, we can add another 2 bars so that we are not changing the dimension of freedom. So now we can see it's working like this. Sorry, I want to adjust the point a little bit. Great. So now the system is working like this, and we can add another like triangle to the 10 bar. So this is just going to be stable. Also, I want to adjust the points a little bit. So now this linkage now does it look familiar to you? Let's zoom in a little bit to see more of it. Does it look familiar? Yeah, so actually that's what is happening in the strand beast. In the strand beast that Theo Jensen creates. So this is the 11 holy numbers of Theo Jensen's work. So Theo Jensen, that he actually that these are all the linkages that he studies, and he calculate all the lengths, and also that he did many physical experiment to get the idea of which is the most appropriate length of all those 11 linkages. Yeah, so that's what is happening there. And Let's start a new one. I'm going to analyze a new linkage now. You can now see the power of that. How could we combine the rules, the very simple rules I said here, that you can create complicated linkages. Now let's start a new one. And yeah, now I am first going to try to use this example. If we add another crank to a 5-bar linkage, if we add another motor, because a 5-bar usually it has a dimensional freedom of 2, so that we need 2 motor. So if we have a motor like this, so this is a 5-bar linkage. This is not going to work for now, but if we add another motor at this point, and then it's working. And also that we are also free. So now what it means is that the bar 2 is rotating around this fixed point, fixed pivot, and also bar 3 is rotating around bar 2, this like moving pivot. And by making the speed of this second motor a little bit different, for example, we change this to 6 and this is 3. So that means that this is like 2 times the speed. This motor is actually the 2 times the speed of this motor. So it will show us a different track. If we've made it to like something like 9, 3 times, so it will show us different patterns. And yeah, that is a 5-bar linkage and it now is working very well. Let's appreciate it and look at the movement a little bit. And also we found that by changing the speed of here is actually changing that how frequently this is shaking. But the biggest shake is determined by how frequent or the speed of this first motor. So you can see that this is vibrating a little bit, like vibrating 3 times every time it finish one pendulum move. Yeah, and then we also learned how could we make something a lever. So let's extend this bar a little bit. And yeah, it so looks so interesting, right? So that this kind of shape is now transformed into a really another very cute shape here. And then what we can do is that from this point, actually, so this is our crank, right? And from this point, and from this point and this point, I want to add 2 bar to connect it because this point and this point, they both have a given track right now, so that I'm allowed to make 2 bar in between them and without changing the dimension of freedom. So let's add another bar here and here. So by adding 2 bar between 2 points that already have a given track, which means that in our application, it shows a blue track, that we are not changing the dimension freedom, which means that this will also work. Now it looks something like this. And then I want to add a point here. And also I want to add another point like here. And so the 2 points I just made, it all have a given track because it's like a point on the one of the bar. And I am also allowed to create another 2 bar in between it so that it doesn't change the dimension of freedom. Sorry, I accidentally drew this. we can apply this rule a little bit more. For example, we can add another point here on the bar 8, and we can add another point here on the bar 6. Now we connect these 2 points with 2 bar, and it doesn't change the dimension of freedom, and it works, and it now looks like this. And we can try to extend this lever a little bit. I'm going to extend these 3 lever. And by changing the way of combining these linkages, and I can change the way all the tracks. So does it remind you of anything? And actually what I am creating just now is actually this piece of art. But this is, I think I need definitely more adjustment. So right now you can see that there is an inner gear here and there is another 2 gear here. So I am just using linkages instead of the gears to try to represent it, the movement. But if you appreciate the movement a little bit, and you can actually find what it is. So actually here, looking at this point, being focused on this point where my mouse is looking at, where my mouse is pointing. So this is a fixed point. And now you can see that this is swaying this point back and forth like a pendulum, which is actually what is happening here. And yeah, so if you try to compare this movement with this movement, you can actually see that it's actually related and it's really yeah, so that's it. That's how that all those very complicated artworks can be analyzed by applying like 4-bar linkages. It all starts with a 4-bar linkage, but also by adding some like triangle and by adding some more 2 bars that we can actually create something that looks really complicated. And it's also really great if we adjust all the points here and we can try to gradually find a movement that seems to be interesting for us. That's more, feels more natural, right? That we can, by adjusting all the points here, that we can get a more and more natural movement that we like. And now it looks a little bit more interesting than the previous. But yeah, so I hope you enjoy this more advanced, a little bit more advanced linkage workshop, and also that you can try to build all the linkages, like how to replicate all the movements and try to see artworks and analyze it. If you did one of those, I will really appreciate. And I'm also really curious about other examples of linkage artworks. And that's it. Hope you enjoyed today's video and welcome to Kinetic Sculpture Club anytime. Wait, I need to stop the recording.